Hello everyone, I am Said Purmayed. Welcome to my YouTube channel. In chapter 4, I'm going to explain how to apply some simple function on columns in a data frame. In part 1, I explain how to reform columns, for example, how to drop a specific columns from a data frame, how to rename columns, and so on. And in part 2, I will explain how to do some simple mathematical function on columns in a data frame. For example, how to add two columns with numerical values, how to multiply two columns with numerical values, and some simple math functions like that. And in part 3, I will talk about SumIF, AverageIF, and CountIF. In this part, I will explain how to find sum, average, or count of a column by conditioning on other columns in a data frame. And in part 4, I will present some time-related functions. For example, how to add a specific number of days to a column with date format, how to find time difference between two columns in terms of days, and some functions like that. So let's go to part 1 and see some functions for reforming columns. First, I provide you some examples in the Python script. Then we will back and summarize the syntax in this slide. So let's see the Python script. As you see in the first cell, similar to other Python script, I read all required libraries. And then in the second cell, I read Excel file InputData, which is stored in this path. Then I read different tabs in this Excel file, and I store them one by one to a specific data frame. Additionally, I read Access database AccessInput, and I read supplies table in this Access database, and I store it to a supplies data frame. Now, in the following, I want to explain how to drop, rename, reorder, and sort columns in a data frame. First, let's see how we can drop some specific columns from a data frame. For this purpose, I can say retailers data frame that shows the information related to retailers. And then in example below, I want to focus in this data frame and drop columns country, manager, and construction date. So as you see, I write the name of data frame here. Then I use .drop function. Then I list the columns that I want to drop. And finally, I use access1 to make sure that I want to drop columns. If you use access0, it means you want to drop rows. And if you use access1, it means you want to drop columns. Since the purpose here is to drop columns, I use access1. So in retailers data frame, I drop 3 columns and I store the resulting data frame to a new data frame and I call retailers data frame 1. So as you see in retailers data frame 1, we don't have columns country, manager, or construction date. So it's the way to drop some specific columns from a data frame. And please note that in this example, we drop columns from retailers data frame and then I store the result to a new data frame. So it means retailers data frame still has columns country, manager, and construction date. But retailers data frame 1 doesn't have those columns. So data frame 1 doesn't have those columns. But if I print retailers data frame here, which is the original data frame, has columns manager, country, and construction date. So let's see the next example. In this example, I want to explain how to drop a specific columns from a data frame by using the index of the columns. In Python, the index of the columns starts from 0. So in retailers data frame, the first column is retailer number, so it has index of 0. The second column is country, so it has index of 1, and so on. So we focus on retailers data frame, and we want to drop columns with index of 2, 5, and 7. And again, by using access1, we make sure that we want to drop columns. So columns with index of 2, 5, 7 are size, address, and number of employees. So these columns will be dropped from retailers data frame. And then we store the result to a new data frame and I call retailer data frame 2. So as you see in retailers data frame 2, we don't have column size, address, and number of employees. But still in retailers data frame, which is the original data frame, we have those columns. Let's see the next example. In this example, I want to show how to read a specific columns in a data frame. Again, let's cancel retailers data frame. In this data frame, I want to read only columns retailers number, delivering warehouse, manager, number of items, and construction date. So it's the way to read a specific columns from a data frame. Just write the name of data frame, open 2 brackets, list the columns that you want to read, and then close 2 brackets. Then we store the result to a new data frame and I call retailer data frame 3. So as you see, retailers data frame 3 includes only these columns. In the next example, I want to show that you can even read only one column in a data frame. Again, let's cancel retailers data frame. In this data frame, I want to read only column retailers number. So again, I open 2 brackets. I write the name of columns that I want to read, and then I close 2 brackets. And then I store to retailers data frame 4. So as you see, retailers data frame 4 includes only one column, which is retailer number. So let's see the next example where I want to explain how to rename columns. In this example, I can say purchase order lines 2023 that shows the purchase information for year 2023, and I want to rename some columns in this data frame. For example, I want to rename item number to item NR, promise delivery date to prompt del date, and order quantity to ord quantity. So here I write the name of data frame dot rename, and here I want to mention that I want to rename columns. That's the original column name, and that's the desired column name. So original column name, desired column name. Here original column name and desired column name. So as you see, item number is renamed to item NR, promise delivery date is renamed to prompt del date, and order quantity is renamed to ord quantity. So that's the way to rename some columns in the data frame. Let's see the next example where I want to explain how to change the position of columns in the data frame. Let's cancel retailers data frame 1, in which we have retailer number in the first position, size in the second position, and so on. Now in the example below, I want to explain how to change the position of the column. So in retailers data frame 1, I want to reindex or reposition the columns, and I want to bring retailers number in the first position, delivering warehouse in the second position, number of items in the third position, and so on. So as you see in the resulting data frame, which is retailers data frame 2, we have retailer number in the first position, delivering warehouse second position, number of items third position, and so on. So that's the way to change the order or position of the columns in the data frame. And let's see the next function, which is sorting column name alphabetically. So in this example, I focus on retailers data frame 2, and I want to sort column names in this data frame. And then I store to the same data frame. So as you see, address is the column name that starts with A, so it takes the first position. Then we have letter D here, so delivering warehouse takes the second position. Then we have letter N, so please note that these two columns have a tie, so NO is the same. Then we need to compare E with I. Since E comes before I, so number of employees takes the third position and number of items takes the fourth position, and so on. Please note that sorting column names alphabetically is very important in some analysis. Here I provide you one example in Excel file where I explain why sorting column names alphabetically is important. So let's suppose that we have data frame like this that shows sales quantity over months for some specific items. For example, we have item number A, B, C, and D, and this one shows the sales quantity. And let's suppose that they are column names. So in this data frame, if we sort column names alphabetically, you can see the sales quantities over month in a proper way. So this column name means year 24 January, this column means year 24 February, year 24 March, and so on. In this data frame, since column names are sorted alphabetically, we ensure that M01 comes before M02, M02 comes before M03, and so on. So by sorting column names, we bring the sales quantities over month. Let's back to our slides and summarize the syntaxing. So first I explain how to drop some columns from a data frame by using column names. Then I explain how to drop columns from a data frame by using the column index. And I also explain that the index of columns, like index of rows, always start from 0. And then I explain how to read some specific columns from a data frame and store to a new data frame. And let me explain you one important note here. Sometimes you want to apply a function on a data frame and then store the result to the data frame itself. For example, in case below, I want to drop some columns from a data frame df and then store the result to a data frame df itself. I can do that in two ways. One is to use .drop function in data frame df and store the result to data frame df itself. And in another way, I use .drop function and I use InPlaceTrue. When I use InPlaceTrue, it means apply this function on data frame df and then store the result to data frame df itself. I generally use the second way because I can decide to store to a data frame df itself or to a new data frame. And moreover, I explain you how to rename columns in a data frame. So it's the syntaxing. I explain you how to change the position of the columns in a data frame. So that's the syntaxing. And finally, I explain you how to sort column names alphabetically. And through one example, I demonstrate why sorting column names is important in some analysis. Next, let's go to part 2, where I want to explain some simple mathematical function on columns. First, I provide you some examples in the Python script. Then we will back to this slide and summarize the syntaxing. So let's see the first example. Let's cancel custom order lines 2023 data frame that shows the order of our customers in 2023. So in the first example, I want to explain you how to assign a specific string to a column in this data frame. For example, in this case, I want to add retailer name to the data frame and I want to set the value of all records to big size retailer. So as you see in this data frame, retailer name is added and the value of all records is big size retailer. In the next example, I want to assign a numerical value to a column. So in this case, I want to add retailer size to the data frame and I want to set the value of all records to 128. So in the resulting data frame, retailer size is added and the value of all records is 128. And in the next example, I want to explain how to add a new column and set null values to all records. I mean, I want to add a new column with empty values. So in this case, I add a column and I call it number of customers and I set it to null value. So if you open one quotation and then close it immediately, it means null value. So in the resulting data frame, number of customers is added with empty values in this column. And in the next example, I want to explain how to generate some random integer numbers from a specific range and assign it to a new column. So in this example, I want to generate some random numbers in range of 15 until 700 and assign those random numbers to number of items. In this regard, I can use npRandInt function. Here we can specify the range of random numbers and here you can specify the number of random numbers that you want to generate. As I explained previously, .shape0 shows the number of rows in a data frame. So data frame .shape0 is the number of rows in custom order line 2023, which is 2000. So by applying this function, we generate 2000 random numbers in range of 15 until 700 and assign them to the number of items. So here as you see the number of items as a new column is added and in this column you can see the random generated numbers in interval 15 until 700. Please note that in this function, 15 is included in the range of random numbers and 700 is not included in the range of random numbers. And in the next example, I want to explain how to assign numbers that start from a specific number with a specific step size. So in this example, I want to assign number 15 to the first row, and I want to increase this value by 9 until the end of the data frame. I mean, I want to assign 15 to the first row, then 15 plus 9, 24 to the second row, 24 plus 9, 33 to the third row, and so on. So as you see here, I define the starting point, here I define the step size, here I define the length of data frame, and by using range function, I generate those numbers. And I assign those numbers to a new column and I call it new ID. So let's back to our slides. Through some examples, I explain you how to assign a specific string to a column, how to assign a specific number to a column, how to assign null values to a column, how to assign a specific date to a column, how to generate some random numbers in a specific interval and assign them to a new column, and how to assign numbers starting from a specific point with a specific step size. So let's go to the next section of this part where I want to explain simple mathematical function on columns. So let's go to the Python script and see some examples. This time I want to focus on items data frame and I want to do some mathematical function on columns in this data frame. Let's see the first example. In this example, I want to increase the selling price by 15%. So we can say in item data frame, we multiply all values in selling price column with 1.15 and we store the result to the same column. So it means the selling price values are increased by 15%. Let's see the next example. In the next example, I want to find the weeks of on hand for each item number. Weeks of on hand means how many weeks of demand we have stock on hand. For example, for this item number, we have 14 pieces of stock on hand and we have weekly demand of 4.3. So 14 divided by 4.3, around 3 weeks of stock on hand. So in item data frame, on hand divided by weekly demand returns weeks of on hand. So in this data frame, 14 divided by 4.3 is 3.2, 0 divided by 2.9 is 0, and so on. So as you see, Python does a vector-based calculation. I mean, he considers on hand as a vector and weekly demand as a vector. Then it divides the first element in on hand with the first element in weekly demand, the second element in on hand with second element in weekly demand, and so on. So this vector divided by this vector will result to weeks on hand and it returns this vector. And one important note here, when you want to do some simple calculation in columns, you need to first handle null values in those columns. So here in this step, I fill null values with 0 and thereafter I do this calculation. So let's see the next example. In next example, I want to find days on hand. So first I find weeks on hand, then times 7 will return days on hand. So as you see, a column days on hand is added here, which is actually weeks on hand times 7. So this one times 7, 0 times 7, 6.3 times 7, and so on. Let's see the next example. In this example, I want to add 1 week of demand to a stock on hand. So I want to add a column to a data frame and I want to call it on hand plus 1 week of demand, which is on hand plus weekly demand. So I have one column here on hand plus 1 week demand, which is on hand plus weekly demand. 14 plus 4.3, which is 80.3. In the third row, I have 40 plus 6.3, which is 46.3, and so on. So it's the way to add 2 columns together. Let's see the next example. In this example, I want to calculate the total size occupied per item. For example, this item number has 14 pieces of stock on hand. The size of item is 0.59. So 14 times 0.59 is the total size which is occupied by this item. So we want to create a column and I want to call it total size, which is on hand times size of the item. So we have 14 pieces here, 14 times 0.59, which returns total size of 8.28. So in this column, I calculate the total size which is occupied per item. Again here, please note that in column size, we have some null values. So before doing this calculation, I fill null values in size with average of size values in this data frame. And thereafter, I do this calculation. I already explained how to handle null values in chapter 3. One of the approach to handle null values is to fill null values with 0, is the one that I do for stock on hand. And the other approach is to fill null values with mean of the existing values. And it's the one that I do for column size. So let's see the next example. Let's consider selling price in item data frame. I want to round up these values to the nearest greater integer. And for this purpose, I use apply npSale function and then store result to selling price sales. So by applying this function, you will see a new column selling price sales is added, which is round up values of selling price. So 72.5 is rounded up to 73, 70 is rounded to 70, 26.1 is rounded up to 27, and so on. And in the next function, I want to explain you how to round down numerical values in a column. So again, consider the selling price in item data frame. Then by using apply npFloor function, I round down the values in selling price and I store them to selling price floor. So selling price floor is round down of numbers here. 72.5 rounded down is 72. 70 rounded down is 70, 26.1 rounded down is 26, and so on. So it's the way to round up and round down float numbers in a column. And as you already recognize, if you have integer values, the round down and round up is equal to that integer value. So in this row, we have 70 as integer value. So round down and round up are the same until 70. Now let's back to our slides and summarize the syntaxing. In the first section, I explain how to do some simple mathematical function. For example, how to multiply a column with a specific number, how to multiply two columns, how to divide two columns, how to add two columns, and so on. Here I explain how to find the power of numerical values in a column. For example, suppose that in data frame df in column name we have some numerical values, and I want to find the power of 2 for all those numerical values. So I can use np_power function, apply it on data frame df on column name, and use n equal to 2. So in column new column name, you will see all values in column name to power 2. Or for instance, when you want to calculate the square root of numerical values in column name, you can use n with the value of 0.5. Or if you want to find the inverse values in the column name, you can use n equal to -1. So in this function, n can take any real values. And finally, I explain how to find round up and round values in columns with numerical values by using npSale and npFloor function respectively. We use npSale to round up and we use npFloor to round down. So let's go to part 3, where I can explain how to find SumIF, AverageIF, and CountIF. In this section, I want to explain how to find sum, average, or CountIF for a column in a data frame by conditioning other columns in the data frame. So let's see some examples in Python script to understand these concepts. In the first example, I want to find the sum of lifetime of items where the weight of those items is greater than 200. That means in item data frame, first filter on the items with weight greater than 200 and then sum up the lifetime of those items. So if I go to the input data in item data frame and filter on weight greater than 200, you will see the sum of lifetime is 3812, which is the same as this value. In the next example, I want to find the average of weekly demand for items with weight of greater than or equal to 340. It means an item data frame first filter on items with weights greater than or equal to 340 and then find the average of weekly demand for those items. So if I go to input data and I filter on weights greater than 240, and then we can find the average of weekly demand, which is 4.36, and it's the same as this value, 4.36. In the next example, I want to find the number of items with demand class C, where the weight of item is less than 300 and weekly demand is greater than 3. So that means first filter on items with weight less than 300 and weekly demand greater than 3, then count how many items has demand class of C. So let's go to our input data, weight less than 300, weekly demand greater than 3, and let's see how many demand class C we have. So as you see, we have 6 items with demand class C, which is the same as this value. So as you see in these examples, I find sum of lifetimes if weight is greater than 300. I find the average of weekly demand if weight is greater than or equal to 340. And I find the number of items with demand class C if weight is less than 300 and weekly demand is greater than 3. So we find sum, average, and count of a column by conditioning on other columns in the data frame. And finally, here you can see the summary of our syntaxing. Now let's go to the part 4, where I want to explain some time-related functions in Python. In this section, I explain how to generate some random dates in Python, how to add some specific dates to a column with date format, how to find time difference between two columns with date format, and some functions like that. So let's go to our Python script and see some examples. So in the first example, I can see the custom order lines 2023 data frame that shows our customer orders in the year 2023. Now I want to apply some time-related functions on this data frame. First, let's apply .info function in this data frame to see the format of each column. As you see in this data frame, order date has the date format. So the format of date in Python is date times 64. Now, in the first example, I want to explain how to convert the column with date format to a string format. So as you see, order date in custom order 2023 has a date format. Now I want to apply this function to convert the column with date format to a string format. So we can say data frame and the column name, and here you can define the format of date with the string format. Here D means date with 2 digits, B is the format of the month, and year is the format of year with 4 digits. And here you can see the format of order date in new data frame. Let's see different format in our slides. So if you have data frame df with call date with date format, then by applying this function, I can convert column with date format to a string format. And here are different formats. For example, if we use this one, you will see date with a string format like this. So as you see, by applying this function and convert order date from date format to a string format. And as you see, if I use .info function, the ordered date now is in object format or text format. So it's not in the date format anymore. And in the next example, I want to explain how to convert the date with a string format to a date format. So as you see in the previous step, I convert ordered date to a string format. Now I want to apply pt to datetime function to convert ordered date again to the date format. So by applying this function, we change the format of ordered date from a string to the date format again. Now let's see the next example. In this example, I want to explain how to add a specific column to a data frame and assign a specific date to that column. So in this case, I add contract date to the data frame and assign 26th of October to all records. So as you see, contract date is added and the value of all records is 26th of October. So it's the way to add a specific date to a column in a data frame. Let's see the next example. In this example, I want to generate some random dates to a new column. For this purpose, we can apply this function. Then we generate random dates in this interval for all records in the data frame. So as you see, end date as a new column is added, and random dates in interval 1st of August till 28th of November is generated for each record. So it's the way to generate some random dates on a specific range in this data frame. And let's see the next example. In this example, I want to generate some random dates that is starting from a specific date and then go forward with a specific step size. For instance, in this case, I want to assign 23rd of October to the first row, and I want to go forward with 3 days and assign those dates to a new column, and I call it new date. So as you see, new date as a new column is added, and the first row is 23rd of October, and then we go forward with 3 days till the end of the data frame. Let's see the next example. In this example, I want to explain by using this function, you can get the date of today. So today date is 28th of December 2024. And if I want to get the days of, for example, 5 days later, I can use this function. So today is 28th of December and 5 days later is 2nd of January 2025. And if you use, for example, here -5, you can get the date of 5 days before, which is 23rd of December. Now let's go to the next example. In this example, I want to explain how to add a specific number of days to a column with date format. So in this case, end date has a date format, and I want to add 4 days to that date. And I store them to a new column, and I call it 4 days after end date. So as you see in the first record, we have 10 of August 2023. 4 days later is 14 of August 2023. Here we have 13 of December, and 4 days later is 17 of December. So it's the way to add some specific days to a column with date format. Let's see the next example. For the next example, I first generate some random numbers in range of 1 to 10 and store them in column random number. Then in the next example, I want to add those random numbers to a new date and store them to a new column. For instance, in the first record, we have 23rd of October. 23rd of October plus 8 days is 31st of October. And 29th of October plus 4 days is 2nd of November, and so on. So I add this number of days to a date in this column. Okay, let's see the next example. In this example, I want to explain how to find time difference between two columns with date format. So new date is in date format, end date also is in date format. Now I want to find the number of days between these two dates, and then I store them to a new column, and I call them diff days. So time difference between new dates and end dates are reported here. Let's go to the next example. In the next example, I want to focus on retailers data frame. And on this data frame, I want to explain how to convert columns with date format that are actually in integer format to a date format. So let's consider construction date that shows the date of construction, but the date in this column is in integer format. So now by applying pd_date function and mapping a specific format, we can convert construction date in integer format to a date format. The important part of this function is this format, and you should use this format by looking the format of the construction date. Let's see some examples in our slide to understand the functionality of this function. So if you have date with integer format and 4 digits are year, 2 digits months, and 2 digits day, then you should use this format. And if you have integer dates with 2 digits year, 2 digits month, and 2 digits day, then you should use this format. Here use capital Y, and here use a small y. And if you have integer date that shows 4 digits year, 2 digits month, 2 digits day, 2 digits hour, 2 digits minute, and 2 digits second, then you should use this format. So this format depends the format of the integer date. So if you apply wrong format here, the corresponding date format of this integer date will be wrong. So let's back to our example. In this case, I look at the construction date, and based on that, I come up with this format. As you see, a new column construction date is added, and the format of the construction date now is in the date format. So we convert the date with integer format to a date format. And if I apply .info function on this data frame, you will see the construction date is in date format. Finally, in the last example, I want to explain how to convert the column with date format to the integer format. So let's consider construction date, which is in date format now. Now I want to find the corresponding integer format of this date. For this purpose, I use this function to convert date to the string format, and then I use asTypeIn function to convert that string to the integer. Again, I define this format based on the format of the construction date. So in this step, I convert date to the string, and then finally that string to the integer. Finally, in column construction date integer, you can see the corresponding integer date of this date. So it's the way to convert the column with date format to a column with date integer format. And in chapter 6, I explained why having column with date integer format is sometimes important. Now let's go to our slides and summarize the syntaxing. In the first function, I explained how to convert the column with date format to a string format, and here you can see different formats. Then I explained how to convert column with a string format to a date format, how to assign a specific date to a column, how to generate some random dates on a specific time interval, how to assign date starting from a specific date and going forward with a specific step size, how to find the date of today, how to find the date of x days before or after today, how to add or subtract a specific number of days to a column with date format. In this function, x is a specific number, and in this function, number of days are reported in a specific column in a data frame. So the same functionality. In this case, x is a number, but in this case, x is reported to a column. And next, I explain how to find time difference between two columns with date format in terms of days. And here I explain how to convert date with integer format to a date format, and here you can see different formats. And finally, I explain how to convert column with date format to a column with date integer format.